Welcome back. I think we are ready. So the next session is going to be chaired by Mr. Kule Chitepo, who is with Resilient Waters Program, and he is the Chief Partnership Advisor. Mr. Kule Chitepo, over to you, and thank you for accepting to chair this session. Thank you.
Good morning, colleagues, and thank you very much to you, Mr. Munyai. I have the honor of chairing this session, sub-theme titled Groundwater as an integral part of the hydrological system. We are running a little bit late, so I will try and ensure that we stick to the time that has been provided, the 15 minutes that has been provided by the organizers for each presentation. We'll go through 5 presentations, and then we will have a question and answer session after that, and then we will go into another set of presentations and then a question and answer session before we break for lunch and end this session. I am assisted in this session by our rapporteur, Mr. Lindelani Lalumbe. He's an hydrologist from the Department of Water and Sanitation in South Africa. Thank you, Lindelani, for assisting with capturing the key points that are emerging from the presentations, as well as from the question and answer session. In terms of how best to address comments, I think let's try and capture your questions in the chat, and that will assist us also in making sure that we have a record of the questions that were asked. And although during the question and answer session, I may also accept some hands that are raised, but let's try and by all means to capture the questions or comments in the chat. So thank you. Without further ado, I would like to introduce our first speaker, our first presentation, sorry, which is presented by a group of professionals: Liberty Gona, Webster, Kumindoga, Donald Rasoka, and Richard Owen. Their presentation is entitled Impact of Climate Change on Groundwater and Potential Recharge of Drought-Prone Areas in the Runde catchment of Zimbabwe. Over to you for your presentation.
Okay, thank you. My name is Liberty Gona. I'm presenting on the topic on behalf of Webster, Donald, Richard Owen. The topic is impacts of climate change on groundwater potential and recharge in the Runde catchment of Zimbabwe. The contents of my presentation: introduction, objectives, study area, materials and methods, results and discussion, conclusion, and recommendation. Globally, groundwater potential is used as domestic and agricultural water. This is used by an estimate of 2 billion population in the world. About 1.4 of the land in Africa is said to be irrigated by groundwater, whereas about 15% of Asia is also irrigated by groundwater. This shows us there is untapped water availability in Africa that is not being used. Runde is one of the 7 catchments of Zimbabwe, and it's a drought-prone area which sits on arid regions, which has recurring droughts due to climate change impacts. The climate variables like temperature, precipitation, and evapotranspiration were extracted from general circulation models, which were done through the Codex model. In the Codex models, the extraction of climate variables were done, and downscaling was also done in the Codex model using the ARA software and the ARA Studio. On justification of this research, UN Millennium Development Goal number 7 talks about the improvement of water, sanitation, natural resources, and reversing environmental losses. In Zimbabwe, groundwater potential is being estimated through geophysical siting, and validation is being done through the open water bodies and the bore yield capacity. Problem statement: information about the spatial variability of aquifer is scarce in Zimbabwe, and this is yielding unsuccessful drilling in the country. There is notable groundwater depletion in Zimbabwe, as you can see from the picture to my corner right. There is pressure on the bore. This is caused by people moving from long distances trying to fetch water because other bores are not yielding much water and some have dried up. The future climate change impacts on groundwater potential is not known. Objectives. My main objective is to assess the impact of climate change on groundwater potential of Runde catchment in Zimbabwe. To determine the spatial variability of groundwater potential in Runde catchment, a drought-prone area in Zimbabwe. To analyze the spatial temporal variability of groundwater recharge. To analyze downscaled future variables and present variables for Runde catchment that has been extracted through GCMs. To assess the impact of climate change on groundwater potential. The questions that has been asked by the generality of the people. What is the temporal and the spatial variability of groundwater potential? To what extent does climate influence groundwater potential and the recharge? How significant are the shortages or surpluses groundwater allocation? What effect does spatial and temporal on future groundwater potential? The study map shows Zimbabwe map and the Runde catchment. This shows the key settlement, the river systems. In this, there are socio-economic activities that takes place. There is gold panning along the streams. There is the tourism and fishing that takes place for the water sources like Lake Meteoric in Masvingo. Materials and methods. Most spatial data was acquired from satellite remote sensing. Other spatial data, soil geology and lithological, was found from Zimbabwe Geological Map Survey. GIS-based multi-criteria evaluation analytical process was carried out to process the predictors of groundwater potential. This is a flow chart of the methodology that was done through QGIS and the ILWIS to produce groundwater potential zones. Materials and methods continuous. Climate variables projected were obtained from 6 GCMs. These GCMs were logged in Codex Africa manual that was done through the extraction, the downscaling, and the process, the analysis of data through Manicandle and the XLStat. This is a chart that shows the 6 GMs that were used to extract climate variables. The predictors are as follows. In the first 8A, there's soil type, there's geology, there's land use, there is the elevation, there is a slope, there is rainfall, drainage density, and topographical index. This is the map of the recharge. The recharge was done through 3% of the rainfall that is received in the catchment. And this was taken from the citations that were observed in the literature. The groundwater potential. Our groundwater potential is varied from low to very high. Very high areas are areas with a high groundwater potential are areas with a high elevation. And these areas at times they have microclimate. There are large water bodies that are housed in this catchment. And we can observe that there is a recharge that we expect in these areas because of, and the area also mitigate the effects of climate change. Validation was done using the borehole attributes. The attributes contained here was a GPS, borehole yield capacity, borehole depth, and water level. In this validation, it was observed that the R squared for the borehole yield capacity against a groundwater potential index was strongly correlated to 0.6. The extracted data from the GCMs was downscaled through the Codex manual, and these are the observations that were obtained from the 6 rain gauge station, which is Buffalo, Masvingo, Rutenga, Mberengwa, Zaka, and Shavani. Below is the information that tells us the projection that has been done for the groundwater potential of Runde catchment. These maps were produced by basing much on the precipitation that has been projected from 2020s to the 2080s. That was the 20 years of projection which was done. And below is a summary of the area of the groundwater potential and the percentage increase that has been observed. For the low, there was the areas, and the total area of the catchment is 42,364.75 square kilometers. For my conclusion, GIS and remote sensing can handle complex data for groundwater potential prediction. This data that has been obtained from remote sensing through the Earth Explorer, these are soil type geology, land use, slope elevation, rainfall, and topographical index. Runde groundwater potential and recharge map was produced using GIS and remote sensing. There is an average variation of 10.5% on groundwater potential due to climate change. And this has been affected by the climate change variables that has been downscaled, which has shown some variations in precipitation and has caused some areas to increase in their groundwater potential, thereby reducing also the areas that had low groundwater potential to become moderate, high to very high groundwater potential. Recommendations. Soil and water conservation strategies in the country. The stakeholders that does management of water, soil and water conservation should craft their policies that are friendly to produce good results of groundwater potential when we talk of moderate, high, and very high, so that we will not have a lot of areas having low groundwater potential, especially the low-lying areas that now receives low rainfall. The rural water information management system database should be always updated. For the information that we have obtained from the WIMS, some of the information had no borehole yield capacity. It was not well updated. So updating this information will give information that will be helpful for the future projects and research. Automatic weather station is in this case mandatory because the standard weather stations are affected by errors, and at times they don't give accurate results. This is the end of my presentation. Thank you, Siawonga, that end.
Thank you very much, Liberty. That was excellent in terms of timekeeping and extremely informative. And thank you to your colleagues as well. We will now move to the next presentation, which is on subsurface characteristics. My apologies. Subsurface characteristics and evaluation of groundwater potential zones in Ibi Ayumre in southwest Nigeria. There are a couple of colleagues, I'm not sure which will be the one presenting, if it will be Adedeji or Adekunle. Okay, we don't seem to have them ready. Marco, would you be ready to give your presentation? If you are ready, then we could just move to your presentation. Are you ready, Marco? I can see that you are online. Okay, good. Thank you, Marco. And then hopefully we'll get Adekunle to come in after yourself. Thank you, Marco. Go ahead.
Good morning to everyone from Germany. My name is Marco Paulo, and I'm a finalist student of geology from the Natural Science Faculty of the Agostinho Neto University. And I'm honored to be here with my supervisor, Professor Dr. Gabriel Luis Miguel, to share with you the preliminary results from my studies, from my monography on rainfall recharge of shallow aquifers from Ongiva and surroundings, Guarani Province, Angola. For this presentation, we will share with you a little bit of the framework of the study area, what are the main problems and motivations, the set of methodologies that we are using for achieve the main goals of the study. So then the preliminary results that we have been achieving by the field work and also the laboratory tests that we have made, and also the technical and scientific contribution that these works brings to the society, because it's very important in this presentation or in this form, which the theme is toward the resilience of Africa, right? So we have to give this point to you also. So as it was known, the city of Ongiva, which is the capital of the Guarani Province, and is inserted also in the Angolan part of the Kuvalaya-Tosha transboundary basin, which is shared with Angola and Namibia, with about 300,000 inhabitants, have suffering along many years with two major problems, two major extreme hydrological problems, which are the drought and floods that has been occurring along many years in Ongiva and surroundings. It happens because sets of variables such as climatic, environmental, and also technical topics that requires a deeper characterization, to better understand the problem, the phenomena, and of course make better decisions. So the main problem is that the scarce, the inaccurate, the dispersed, and also the outdated hydrogeological information in this area, it's a major obstacle in the elaboration of a strategic plan to artificially recharge the shallow aquifers using the waters that are available during the periods of flooding and inundations in that area. And it is a way, it will be a way to promote the resilient community in Cunene province, right? Because the recharge, the shallow aquifers are the main sources, and that's why we are talking about that, and creating or promoting this high database and these studies. We are also at the same time promoting the resilience in the community. So to achieve this goal, we have to characterize the rainfall recharge process in order to provide this indispensable data, this information for decision making regarding to the methodologies that can be implemented for the artificial recharge. So the big question may be, why the shallow aquifers? Well, because the shallow aquifers of Ongiva and surrounding, as I said, are the main source of water supply for many communities, for the local people, and are thus the more studies that has more studies and more investments. So in 1966, Motam Marques, during his scientific expedition to Cunene, ordered by the Portuguese Geological Survey in partnership with the geophysics team of the NEC in Portugal, also have identified and characterized the hydrogeological province that was called Delta Cuvalai Mui Pereira Dessa Namapund, which are the group of suspended aquifers up to 50 meters deep, and also the shallow ones with a maximum of 30 meters deep. And the same author, with the results that have been obtained during his studies, presents a scenario where only precipitations above 35 millimeters had a real impact on the effective recharge of the shallow aquifers in that region. And in 2017, the Angola's National Water Plan presented an estimate of 18.5 millimeters for groundwater recharge in the Ongiva region, Cuvalai Basin, right? Without making mention of the methodology used for achieve this purpose. But in general, the main scientist uses the monthly water balance models to get that information. So the configuration of the methodologies used to respond to the main problems that was identified in this study derives from a doctoral thesis on hydrogeological and environmental characterization of Luanda and surroundings, authored by Gabriel Luis Miguel, that guides the steps to be followed for achieve the main goal of this study. But despite of the similarity between the hydrogeology of Luanda and Cunene, in this study we decided to go deeper. We decided to characterize the phenomena related to the physics of the atmosphere by using daily climatic information provided by satellites such as the Tropical Rainfall Measurement Mission by NASA, and also the precipitation estimation from remote sensing information using artificial neural networks provided by the Hydrometeorological Center of the University of California, sorry, because we want to invest in daily water balances, because the monthly water balance models in semi-arid and arid regions promotes the underestimation of climatic phenomena due to their intra-annual variation in precipitations and sharp typical deviation as well. Because in a water crisis, every drop of water counts. So we have to get this approach, that daily approach, to better understand the problem and make better decisions, right? So in that, we said we get these topics, these methodologies. We are using the daily water balance, ALSEC, that was developed by Lobo Ferreira in Portugal, and we are using a series of 37 hydrological years, starting from 1983-84 until 2019, 2020. We are using also environmental isotopes of hydrogen and oxygen, the stable one. I'm talking about the deuterium and the oxygen 18, to identify the origin of the waters that are in the natural reservoirs, such as Catimbas, Chimpacas, and also the aquifers, the shallow ones. So to identify the cycles of drought and floods that has been occurring in Cunene and in Ongiva and surroundings, we are using also the standard precipitation index provided by the World Meteorological Organization, and also using the curve number mathematical method to calculate the rate of infiltration. The focus of this speaking of this presentation is to share with you the methodologies and the preliminary results that we have been collected, and the ongoing analysis that are on the way and will be well presented when I finish my degree in this December. So we had a geological field work that was held between May and June of this year, and we have inventoried about 162 water points, of which 66 corresponds to groundwater catchments. These points were inventoried also by John Mendelson during his expedition at Ongiva and surroundings at 2015. And my points as well during my participation in the scientific expedition led by the World Bank in 2019. So we have collected these 162 water points. So we have collected also 25 water samples that was submitted to majority ion and stable isotopes analysis, and also 15 soil samples that was submitted to the geotechnical test, because we want to know about the permeability characteristics of these formations in order to know the major or the less facility that the water has to infiltrate and also recharge the shallow aquifers, which is the main goal of this work. So as the first preliminary results, we were able to make a preliminary geological and hydrogeological characterization of the study area. And because of the extensive and flat surface of the Guanyama, there is no outcrops, there is with the frequency. So the team resorted to excavations and to study and to identify the lithostratigraphic sequence of the area. And in general, we have identified 3 unities of geological formation. At the base, we find always the white marl, white compact marls, and above it we have a variable thick layer of clay that makes this contact between the base and the top, that is made of red silty sandstone at all extension of the study area. So we have also identified some structures such as channels with carbonated material filling that represents an interruption in the sedimentary history of this area, and also modifications in the lithology that gives a few tips about what happened in that region many years ago. So it's crucial for the paleo-environmental reconstruction of the area. We also have identified some stratigraphic discontinuity by identifying some conglomerates within the marls, which refers to a paraconformity, for example, that gives us this information of the interruption in the sedimentary and then the continuous rising of the rivers and the winds erosion and action on this area. So also we have identified diaclasses with 3 millimeters thick, approximated, in the southeast direction, which where we found or we saw the groundwater flowing from the outside, from the inside to outside. So all this data was crucial to determine and to identify the potential aquifer zones in the region, either the suspended and also the shallow ones. So the suspended aquifers are located in the red silty sandstones in the Mufito area, which is a geomorphological feature of the area, and the shallow ones are located located in the carbonates and the white marls with diaclasses, and so it's all this. It's a system that makes the shallow aquifers of the region, which are the main objective of the study. So
Marcos, we've got a few minutes left, my brother.
Yes, I'm finishing. Thank you.
Thank you.
Regarding to the geotechnical interpretations or tests about the soil samples, we have here, as you can see at graph 2, we have particle of size these curves, when we can see that about 54% of the soil samples was characterized as a silty sandstone by the Unified Salt Classification System, and 55% as of the group to A24 in the High Grade Research Board classification. And we use it a lot of methodologies, but basically we have made the particular size analysis by sieving and also the segmentations, and we have used the constant low parameter for identify or for determine the permeaporosity, the permeability of the materials. We want this because we have to classify the samples in order to have this overview of the distribution of soils in our study area. Regarding to the determination of the origin of the water using the isotopes of hydrogen and oxygen, we have here a graphic of the global meteoric water line, which where we can see that we have the blue line that refers to the precipitation line, and the red line that refers to the evaporation water line. So we see that because of the evaporation process and the isotope fraction process, all all samples that was processed. We had 10 samples, 10 water samples that was submitted to this type of analysis and was processed in the liquid water analysis isotope analyzer. And we can see that all dots are located in the evaporation water line, which means that despite of it has various sources of water, it has
Okay. Marcos, your line is really terrible, man.
Origin that is right. Hello, are you listening?
Yeah, your line was very bad, but if you can wrap up now, that's better. Thanks, Marco. Hello.
So I was saying, we see here that even groundwater catchment samples, water samples, has rainfall origin but was passing through an evaporation before it infiltrates and also recharge the aquifer. So to finish, we have here the technical and scientific contribution of these works. Because of all this information that was collected, we were able to develop the EFUNJA project, which is a flood control project that consists in a geographic information system that integrates essentially climatic and geospatial data that provides to the civil society, the political decision makers, even the private and the public institutions who works in the environmental management field, to have the open access to a broad hydrogeological data that will optimize their works and lifestyles, reducing the number of deaths in Angola by drowning and floodings, and also by the relation of the electricity and water, and also reducing the number of material damages caused by such catastrophe. So this project was presented here at Nuremberg in Germany last week at the International Fair of Ideas, Innovations and New Products, and won a silver medal. So not to go further, thank you for your attention. Obrigado pela vossa atenção. You may contact us. Thank you.
Wonderful. Okay, Primrose, let's have your presentation. It's an assessment of the transboundary Tuli Karoo groundwater resources. Assessment of groundwater resources in the Tuli Karoo Basin. In the meantime, if I may request, if either of Tafadzwa or Abedeji, those two presentations, if you are ready, please be prepared to go next. Primrose, over to you. Thank you very much.
Greetings, everyone. This is Primrose Tinonetana presenting on groundwater assessment in the transboundary Tuli Karoo Basin with Webster Gumindoga, Richard Owen, and Donald Wasoka. Groundwater is the biggest and most widely distributed store of liquid fresh water available for human use. It is used for industrial purposes, agricultural, and mostly domestic purposes. Quantitative estimates of amount and quality of groundwater resources are required in the transboundary Tuli Karoo Basin. This is important for the basin member states to better manage and to promote sustainable conjunctive use of the resource. It is also required by those basin member states to characterize the resource in ways that can usefully inform strategies to adapt not only to population growth, but to climate change and variability. However, there is little or no reliable and current quantitative information on groundwater resources in the Tuli transboundary basin. So this study is relevant in water development policy, water-related development aid, community planning and technical decision-making to catchment managers, water planners, and non-specialists alike. The main objective of this study is to map groundwater potential zones and to model groundwater recharge, as well as groundwater flow in Tuli Karoo Basin. The first specific objective being to map the spatial variability of groundwater potential, to determine the spatial and temporal distribution of recharge, and to determine the groundwater flow of Tuli Karoo Basin. So Tuli Karoo is one of the 14 transboundary aquifers that are found in Southern Africa. It covers about 12,166 kilometers, and it is shared among Botswana, South Africa, and Zimbabwe. So 56.3% of it is in Zimbabwe, 34.1% in Botswana, and 9.6% in South Africa. According to Gomo and Femulin, the aquifer is characterized by shallow water table aquifer systems, which comprises of alluvial formations. It is also found in semi-arid regions where there is high water stress and low moisture deficits. Moving on to the materials and methods. Due to inaccessibility of field-based data, the methods were based mainly on geographic information systems and earth observation. So to achieve objective number 1, that is to determine the groundwater potential, explained later. The data sourcing was done to produce the thematic maps for this study. That is 9 thematic maps that were used. And after the data sourcing, pre-processing was done. That includes subsetting and projection. And then the thematic layers were processed. For example, digital elevation model hydroprocessing, lineament extraction. And then after that, a weight overlay was performed using analytical hierarchy process to come up with a groundwater potential zone map. So borehole yield data and borehole depth data were used to validate this map. In order to come up with groundwater recharge using available data, we used the soil water balance model. This model requires climatic data model, and then it produced a groundwater recharge map. To achieve objective number 3, that is to determine the groundwater flow model, we also used a method that can give us an appreciation using available data. This method is called the British Geological Survey GIS Groundwater 2, which is a seamless coupled GIS model, and it requires groundwater recharge as an input. It also requires aquifer layer transmissivity and digital elevation model. So the groundwater recharge from the SWB model was then used to come up with the groundwater heads together with the other inputs that are required by BGS. And then the groundwater heads map was then used to come up with a map for flow direction. So these are the data sources that were used in this study, with data that were obtained from satellite, literature institutions, and some portals. For example, Landsat 8 image was derived from USGS Earth Explorer, and some borehole yields and depth from SADC Groundwater Management, Groundwater Information Portal. moving on to the results. These are the 9 thematic maps that were used to obtain groundwater potential. The GWP in this case is standing for groundwater potential. So lineaments are defined as linear or curvilinear features on the Earth's surface. It is considered as an important hydrogeological factor when determining groundwater recharge. So it was extracted, it was computed from Landsat 8 image, and then slope and drainage density and topographic wetness index were also computed from the digital elevation model. So all these 9 maps were given weights in order to come up with the final groundwater potential map. This is the result for the groundwater potential map. It shows that Tuli Karoo Basin is dominated by areas of high groundwater potential, covering 57.8% of the study area. It is followed by areas of low groundwater potential, which covers 37.9% of the study area. There's high groundwater potential in areas like Tongwe and Masunga, and some places like Tuli and some parts of Shashe have very high groundwater potential. So map classification of groundwater potential helps for water managers when they are prioritizing development, groundwater development. To validate this map, borehole yield data and borehole depth data was used. A statistical test was done, and also a percentage of borehole yield falling in each groundwater potential class was calculated. So the results showed that it is expected that when we have low groundwater potential, we should have low borehole yields. And when we have high groundwater potential, we should also have high borehole yields. So the results showed that the percentage for low groundwater potential class decreases as the borehole yield increases. So although the factors that were used in this study might not be exhaustive, the map looks to be a reasonable reflection of the situation in the Tuli Karoo Basin. So to determine groundwater recharge, 2 methods were used. The first one is rainfall analysis. That is 3.5% of annual recharge is groundwater recharge. 3.5% of annual rainfall is groundwater recharge. So from this method, the results showed that the minimum recharge is 7 millimeters per year and the maximum is 16 millimeters. Then we estimated groundwater recharge using the soil water balance method. The soil water balance method used available water capacity, hydrologic soil group, flow direction, runoff curve numbers, and some climatic data. So from this method, the maximum recharge was 13.2 millimeters per year and the minimum was 0. The difference in these 2 methods might be explained by the fact that the previous method does not include other groundwater recharge factors like land use, land cover, soil type, and flow direction. Then to estimate groundwater flow, usually groundwater flow is estimated using numerical models such as mode flow. But we could not do it on this case because we did not have the data. So we made use of the available data to come up with an appreciation of what is going on in the basin using the British Geologic Survey GIS groundwater tool. So this method showed that in some parts of the basin, groundwater flows from northwest towards southeast where there is Limpopo River. However, it is it is to be noted that this stage this objective is still on its final stages, and we are still looking for data to produce better results. And we are appealing to all of you, if there's anyone who has the data and willing to share. So we concluded that Tuli Karoo Basin has high groundwater potential indicated by the dominance of high groundwater potential classes, which covers 57.8%, and Tuli Karoo Basin has low groundwater recharge with a maximum of 13.2 millimeters per 10-year average. And then the general groundwater flow in the Tuli Karoo Basin is southeast. So we recommend that reliable hydrogeological data, such as stratigraphic data, borehole water levels, streamflow data should be provided to promote better understanding of groundwater as a resource. And then further studies should be done in the basin using other groundwater recharge and flow estimation techniques that uses field-based data. For example, we can use base flow separation method using streamflow data. Also, we recommend the use of numerical models such as ModFlow to determine groundwater flow in the basin. Thank you.
Thank you so much for that wonderful presentation, Primrose, and you did excellent in terms of time. So thank you again for that. All right, well, if that's the case, then maybe let's then move to the question and answer session, which was scheduled to begin at around this time in any case. So we've had, colleagues, 3 presentations. We've had the presentation given by Liberty, which is looking at the impact of climate change on groundwater potential and recharge of the drought-prone areas of the Runde catchment in Zimbabwe. We also had a presentation from Paulo Carlos, on rainfall recharge in the Ondiva area in Angola, Kunene region in Angola. And then we also had a presentation from Primrose looking at the transboundary Tuli Karoo aquifer and the groundwater recharge issues there, an assessment of that groundwater resources in that aquifer. I think we can open up for a couple of questions. I'll start by looking at the comments that are in the Q&A section. There was a comment directed to you, Liberty, suggesting that the next time you refer to the SDG, Sustainable Development Goals, instead of MDGs, which expired. I think this was just a comment that was given in that from Kahliso. Then there's a question from Kevin Peterson. It says, do you take rainfall intensity also into account or only rainfall amount? He's assuming that recharge is episodic in the region. Liberty, this question is directed to you. Would you be able to answer the question? Liberty? Is Liberty still with us?
Let me check. I will come back to you if he's still on the call.
Okay. And then maybe in the meantime, Primrose, I hope you are still with us. There's a it's a comment, I guess, that, well, the question asking, is there a link between groundwater flow, direction, and surface flow? This is a question from Webster. Primrose, would you be able to answer that question? Primrose, did you get that question? Another question also, there's a couple of questions for Primrose. Is there another way to contact her if she's still on the call?
No, we don't. We can just drop a chair like a message on the chat box, hoping that she will sit and respond. But other than that, there is nothing else that we can do. But I'll drop a message in the chat box directly to her.
Okay, all right, that's fine. And then, so there are a few questions for Primrose. If you can assist by just perhaps what she could do is type in answers. If she goes to the Q&A section, she could type in some of the answers to those questions so that we have a record of her responses. And then there's a general question, I guess, from Moses Mulenga. Is asking, why is Africa as limited access to the latest technology available looking at Africa's problems? How often do you send the students to study these latest technologies? I'm not sure who from the presenters would be, or from the general audience. I'm happy to, if anyone is interested, to put up your hand and we could attempt to answer that question together. I think it's just about Africa's access to technology. But let me see. There's another question about the GIS tool that Primrose used. Unfortunately, she's not available for that question. Just looking here if... So Carlos, Marcos,
yes,
there's a question for you. It's unfortunately it's in the chat, but he's asking what, it's from Nkuba, Michael Nkuba. What was the rainfall recharge of the rainfall in Angola from the study?
Okay. Well, at this moment, we have not yet quantified the rainfall recharge in Ondiva and surrounding, but this will be presented in December. But however, we have reached some preliminary results, and we're able to identify that the recharge is episodic, and to make also interpretations about the origin of water that are available for the effective recharge of shallow aquifers. And we have reached that these are of rainfall origin, and that before the infiltration, they suffer the process of evaporation as presented in the graph of the Meteoric water global line, right? So these are just the preliminary results, and the other ones, we have the ongoing analysis that we are making. And so in December, we will have the specific number and the quantity that infiltrates and recharge in that area.
Okay, muito obrigado. That's a good answer there, man. And then we do have another question from Michael Nkuba, but it's for the presentation on Zimbabwe, but unfortunately our colleagues, they are not available anymore. Okay, my suggestion, colleagues, is that we move on to the remaining presentations. We have 3 remaining. I'm informed that Anions. The first one on the agenda, the presentation about the Odzani River catchment. Apparently, that colleague is not no longer available. But so we have the other three remaining in this session. Can I, just before we move ahead, just double check whether Tafadzwa, Shepherd, or Farai are with us from the previous session? Any one of them still available? No. Okay. Then, Modrek Gomo, are you available and ready to present?
I'm trying to share my screen.
Oh. Is it Adekunle? Okay.
Yes.
All right. Let's try yours once again.
Come on, sir. Yes, sir. My name is Adekunle. The title of my presentation is Subsurface Characteristics and Evaluation of Groundwater Potential Zones of Idianyore, Southwest Nigeria. Outline. The item of my presentation are the introduction, literature review, methodology, result and discussion, conclusion, and reference. Introduction. Global warming, climate, weather, human activities, coupled with population rise of many cities, towns, and villages has led to insufficient water supply. Most communities were searching for an alternative source of water supply because of this result. The water available is no longer sufficient to take care of the populace. The objective is groundwater. All these play a vital role in development, industries, agricultural, and domestic sectors. Introduction continues.
It seems like we've lost him again, Chair.
Okay. I said another one is permeability of the
Oh.
surface. This has to do with the soil that allow the passage of fluid to its. Another factor is the underlying rock formations of the area. Literature review continue. Bishola in 2013 reported that variation in groundwater potential results from porosity and permeability. Adewale 2014 studied groundwater exploration in southwestern Nigeria using VLF and PS. The results compare favorably well with drilling information. We also have among the people that have studied groundwater in the past, we have another one done by Akimidu and Olonfemi. Their title was Capacity of Permeability and Porosity Contained in the Setologies of the term is determined by geological materials. Abebe 2020 carried out groundwater potential mapping using geospatial technologies. In the result, 89% of the spring were overlaying good groundwater potentials, while 58% of deep well has similar trees, and 42% of deep well have overlaying moderate zones. We also have Opoli and Ozomoje 2020. In their own study, they applied battery electrical sounding and EM three dimension to groundwater exploration in southwestern Nigeria. In their results, the VS were characterized by good aquifer resistivity on conductive zones and poor indication on non-conductive zones. The study area. The study area. The geographical condition of the study area is on longitude 7 degrees and 14 degrees and 14 minutes, while the latitude is 3 degrees and 51 minutes east. The major rock association of the study area is made up of basement complex part of basement complex of Nigeria with an undulating topography, where we have the western part of the study area, which is underlain by branded gneiss, while the eastern part is predominantly made up of gneiss, granite gneiss. Figure 1 shows the map of the study area, which is Anions and its environment, area very close to the Anions. Materials and method. Geoelectrical resistivity field data was acquired using Earth resistivity meter, that commonly referred to as thermometer. The specific instrument used in this research is GeoPulse Tiger resistivity meter. That one is shown in figure 2A and 2B. The field work was accomplished in the month of August. The period coincided with a period of drastic reduction in the frequency of rainfall for a few days in the study area. Electrical imaging using Stombaja array was used. A total of 21 VS was carried out in the study. Materials and method continue. We made use of 4 electrodes which are positioned symmetrically along a straight line. The current electrodes C1 and C2 are outside, while the potential electrodes P1 and P2 are placed in between the 2 current electrodes C1 and C2. The 2/3 the length of the electrode were driven into the earth to ensure that good electrical contact is achieved with the earth. The maximum current electrode spacing is AB by 2, which was 110 meters. Figure 2 is the materials that was used in carrying out the resistivity. That is GeoPulse Tiger resistivity meters. The values of the resistor method in the field were multiplied with their respective geometry factor K, which gave the required apparent resistivity result. Partial curve matching was done by matching the plotted curves with a master curve. Through this process, the apparent resistivity and the depth of the layers were also obtained respectively. The procedure was repeated for all the 21 vertical electrical sounding maps, which is shown in figure 3. The other shows the VS points in the study area. Theory. The reflection coefficient R for each of the vertical electrical sounding VS was done using the equation below. In the equation, we have R equals to Pn minus P into n minus 1 over Pn plus P into n minus 1. Where Pn is the layer resistivity of the nth layer and Pn minus 1 is the layer resistivity overlying the nth layer. Result and discussion. There is unfavorable ground potential in the area that cause borehole failure. In a small portion of the area, location of boreholes do not favor groundwater. Generally, the overburdening of the study area is shallow, with the exception of the southwest part, with that has thick overburdening and good for groundwater abstraction. The main units suited for groundwater exploration in the study area is, as indicated in the result, are the vertical electrical sounding VS1 and VS16, respectively. The overburden thickness map of the study area shown in figure 4 range between 1.1 and 44.4 meters, and it has average thickness of 8.7 meters. The overburden within the southwestern part and southeastern part of the study area has thickness of about 44.4 meters and 4.4 meters respectively. Other parts of the study area have shallow, overburden thickness, and indication that the basement is shallow. Figure 4 is the one that represents the overburden thickness map of the study area. Then we have figure 5A and figure 5B that represents a graph of activity against electron distance that was obtained in the study area. These are my reference. In conclusion, the groundwater potential of the study area is low, and this has contributed immensely to the shortage of water during dry season. Thank you.
Thank you. Thank you very much, Adekunle, for that presentation. Thank you for bearing with us.
Thank you, sir. Thanks.
Yes, with the technology. Thank you very much. We will then,
thank you, sir.
I'll just do a final, thank you very much, sir. Let's move on then. Mr. Gomo, Moderator Gomo, are you available?
Okay.
That's it.
Thank you, everyone. I just want to try and remove this. Okay, thank you. Thank you, everyone. I am going to make a presentation on maybe trying to look at estimation of bore sustainable yield in a typical confined porous aquifer. Yeah, with I think with everything that.
Prof?
Yes.
Would you mind putting it on slideshow mode?
Okay, thank you. Thank you. Okay, perfect. I wanted to say, I'm sure we all appreciate that there's always, given the nature of the groundwater resources, invisible and also a lot of uncertainty even for our yields and the bore's sustainability. I'm sure there's always a need to try and improve or even adapt some of the methods for estimation of maybe what we think is reliable yields. So the idea is, I think we all appreciate that estimation of bore sustainable yield is very important in order to be able to operate a bore in a manner which can maintain the aquifer productivity. We also appreciate that that's also important for costing operation, costing and all the other things. Obviously, at the end of the day, we still need some kind of safe, well, I would say probably reliable yield, just to indicate that I know sometimes when we're speaking to other professionals, it's a bit confusing sometimes how we use the term sustainable yield, but that's how we probably use it. We are looking, I don't think we're looking at the productivity, the healthiness of the bore, not necessarily the environment. We're thinking like, well, how can we ensure, obviously, the bore keeps on operating? Of course, we know that at the end of the day, we are not in control of everything. A lot of things, they change in the environment, climate change, additional users, and a lot of other things. So at the end of the day, even if we estimate something today, there's never really any guarantee that that is going to be the same story all the same. But nevertheless, despite the uncertainties that arise with this term, I think we all appreciate that, especially for commercial farming, big, any other big investments, which they want to rely on groundwater. People want to know whether they invest their money so at the end of the day, they want to be able to know, obviously, how much the resource is available and the yield that they can use eventually, taking into consideration maybe the best case and the worst case scenarios. Other terms, I think that we interchangeably used with sustainable bore yield, I think from literature and maybe from the other guys in the other regions as well. Safe yield is very common, also reliable yield. There could be also other terms. For the purposes of the presentation of this study and the proposed application, bore sustainable yield is defined as the constant discharge rate at which a bore can be pumped, operated during the operation life without causing the aquifer to dewater. About the aquifer, I'm talking of a typical porous confined aquifer system. I think that this presentation or the thought about adapting the other method that was there already, because that's what I'm going to try and do, just to illustrate what I think it can be used for the other purposes, that I'm sure a lot of guys who are practitioners agree with me that although I know that one of the keynote presenters indicated that we're still almost at the baseline in most of the regions in terms of the groundwater, but perhaps maybe it is the distribution in Africa that is not always uniform, and also the fact that we also do not have porous aquifers. At the end of the day, I think most of the guys that are involved in the drilling and all the groundwater development work, they would appreciate that over the years, I think in some places we are drilling deeper and deeper, indicating that, well, perhaps there could be stress in the upper aquifers. At the same time, that also highlights that most likely we're going to be dealing with some sort of, whether even if it's fractured or whether deep there, but it's some sort of confined aquifers, which I think poses a big challenge, because at the end of the day, those hills, I think, should be well protected, because we can almost imagine how long it takes for an aquifer that is situated 200 meters, 150 meters deep for it to replenish. And I thought it would be very good for me to emphasize this at this point. So in typical porous confined aquifer, dewatering can occur when the water level is going to drop below the aquifer, below the top of the aquifer. So this is the typical porous aquifer that there is a screening, it's not uniform, but we expect it to be uniform. But what I'm just saying is, can we then try to determine a rate of pumping that we can use for operation that do not allow the water level to drop within below this, so that at the end of the day, because once the water level drops into there, we will dewater this aquifer. And we know for sure that the reason why perhaps the pores are open maybe 150 meters deep is because there's water. If we dewater the water, if we pump and exceed that such that we start to actually desaturate this, what's going to happen is there is compaction, there is a lot of overburden material. We most likely in the long run going to lose even this aquifer, because these pores most likely they are going to close. So in principle, we want to try and estimate that rate. But the idea that I'm using here, it's I think for some of you guys, it's from a well-known method that I think probably is one of the best approaches that I have seen that has been used, is typically in fractured rock aquifer, Fantona 2001. They developed this with the idea of typical fractured rock aquifer. But perhaps, obviously, like I say, I thought when I understand what I understand now, I thought perhaps it's as good as also used in typical confined porous aquifer. So the idea is, imagine this is deep, 200 meters deep. I'm sure some of you guys have drilled deeper than that. So, but how? Let's pump in such a way that at least the water does not drop below this, because once we go into there, we know the issue of the dewatering and obviously the change of the characteristics. So how do I do what I am trying to illustrate? The first component, I will briefly explain, maybe for the benefit of everyone, about this FC approach, which was initially designed to be applicable in typical fractured rock aquifer. Thereafter, I will illustrate through the use of the numerical modeling, perhaps how I think perhaps how this approach can also be used in a typical porous confined aquifers. So just for everyone, the method, it's obviously meant for typical fractured rock aquifer. It estimates sustainable yield, which is I've defined based on, obviously we need to do a constant discharge pumping test for a certain duration, but the longer the better, but we're always limited. Obviously, the longer, the more the cost, but obviously the better for the data. Then in a typical fractured aquifer, an available drawdown is defined whereby it will be said, look here, this is the position of the fracture, pump, but do not go below the position of the fracture for the similar fee as well. Then of course, there is the drawdown that is recorded during the pumping test. What happens, T Long described perhaps the maximum operation time for which a practitioner could recommend a certain yield before perhaps there is review and further try to look how the system is behaving, right? So as available should not be exceeded. That's what is basically available. Do not go below the percent of the fracture. The extrapolation of the measured drawdown, which is during the pumping test to determine Q sustainable, is done using the Taylor series. That's the Taylor function. I will quickly just summarize because also the time. So here, what happens with the method, it looks and say over the long time that we are going to pump, the S over the long time is going to be a combination of drawdown in the well. That's the one we have extrapolated with the Taylor series, but also the method recognize, the approach recognize that while during the pumping test, we may not be able to see the barriers. Those are barriers, eventually they will impede the flow. It also tries to consider the worst case and the best case scenarios. It also tries to say the approach also, if the other methods exist, their drawdown also, their pumping rates and the effects that they can have should also be included. Here, I'm not talking of a well field. I'm looking at a situation of these perhaps individual balls that we do have in a lot of the setups, raw water supply, and I'm sure in a lot of places, farms for irrigation. It's not always that we're going to treat situation as a well field. Yes, numerical modeling would help, but at the same time, if there is two balls, one ball, it will be the cost of developing a model would outweigh actually, I think, the benefits. So the expansion of this over the long time that we want to estimate is done using the Taylor series expansion. Also to consider that whereby I say the method also looks at the possibilities that, well, while we may not see the influence of the boundaries during the pumping, what can happen is as we operate over 2 years, for instance, we may see these possibilities, no flow boundary, 1 or 2 no flow boundaries, and the worst case scenario is a closed no flow boundary. The closed no flow boundary just says we have boundaries from everywhere. And what happens, obviously, the only source of water that we can get is from the storage within the aquifer. So in a nutshell, the method tries to cater for those boundaries. What it does, it introduces imaginary well to the one that is pumping. Obviously, the number of wells will be equal to the number of the boundaries. Then that well acts like as a boundary, because if we have got 2 wells opposite to each other, the other well is pumping, the other well is pumping, then we can see the influence of one off-flow boundary, and the same can be said to the other alternatives. So quickly, this is the extrapolation by the Taylor series, just for the benefit, for the sake of time. What we have there is your average first derivative, average maximum first derivative of the drawdown. Then we also have another one, the second average derivative. It only considers the first two terms, because I think as we expand, the terms keep on going to n, then their influence on the total drawdown becomes very negligible. So what we did, this is the idea, as I've said, the idea is we have our aquifer sitting maybe 100 meters, 200 meters, or 150 meters. But as we try to do our pumping test to determine the yield, we say, let's pump, but we must always ensure that, we must ensure that the rate, the rate that we choose does not cause the water to fall below there. Okay, so what I did was just to try and illustrate. First, I simulated an aquifer pumping test in a typical homogeneous system. These are the parameters that I had. It's just simply like a block model, but obviously you must try to take to appreciate everything that the modeling actually requires. So when we have done that, so this is like a constant pumping test in the field, right? Where we starting from there, we pumping. We assume that the 4 liters per second that was used in this case, it would mean that it would probably have been determined from the step test discharge rate. So this is just the simulated, I think that was for about 14 days or so. I just want to point out this is the derivative in blue, then this is the simulated drawdown. Just to highlight that, you see there we are approaching just about 9. And from our, if you look from our initial head is 24 and our aquifer thickness is 15, you would almost realize our available drawdown, this available drawdown that we were talking about, it's about 9 meters. So right there, we were just getting about close to 9 meters, which is why I think we see some flattening and drop of the derivative there. But it was we would have managed to fully stress the ball, and then I use this data to then say, let me go back to the FC approach, which is well, it's an Excel-based program, which is, I think, free and it's accessible for everyone to be able to use. And I think it's fairly straightforward. There, I'll just highlight what my available drawdown. I used 9 because during the testing, I realized I did not drop the water level. I didn't want to drop the water level into the confined aquifer. It went just about 9, 8.9, just happened somewhere there. So that's my available drawdown. And I used, obviously, the parameters that we need. Average maximum derivative, which is from the Taylor series expansion, then the second derivative. This one we don't necessarily need, but from the equation that I've presented, then the FC method will provide a solution of, first one is assuming you operate 2 years continuous pumping, no stopping, it would say, if you don't encounter any boundary, this is probably the best case scenario. You don't encounter any boundary, then we're supposed to recommend 3 liters per second for the next 2. I think based on this, it was for the next 2 years. Then the worst case scenario whereby you have got boundaries everywhere, and that eventually blocks the water. And where does the water come from? It comes from the storage. And where we use the recharge of 0, because it's a blank shell, but it's a 0 value, because we assume obviously that's the worst case scenario. So to try and test this, then I had two situations whereby I now want to say, if I go and do the modeling now and simulate and evaluate this first rate and also 1.31, what do I get? So what I did, I then used numerical modeling to try and evaluate the performance of those yield that I've estimated. The best case, that was 3, and also the worst case. So this worst case should have been 1.31. So eventually pumping that for 366 days.
We might need to wrap up now.
Okay, sure. Thank you. Thank you. Simulating 366 days. This is the best case, assuming there is no boundaries, but we get very close there to, we get very close there to the 9. But this one is the one with the worst case scenario. Where I placed my boundary is actually on the radius of influence that we had seen during the pumping. What I realized, I think up to 322 days, which is somewhere about there, I could pump for the, I think 332 days at that 1.31 rate without really dewatering my aquifer system, which I think, based on what we say, that would be healthy for the aquifer system. So I'm going to cut my long story short, but this is my available drawdown. And what I realized with this worst case scenario, which is boundaries, then I would have pumped for 332 days, very close to AA, without exceeding there. I think in a nutshell, what I try to illustrate is illustrate the application of method that was developed for initially typical fracture broke aquifer, how it can be used to estimate bore yield in typical confined aquifer. The emphasis, however, is always to on monitoring, and maybe let's adjust the levels accordingly, because we are never in control of the environment and the catchment that affects the yield. Thank you.
Wonderful. Thank you so much, Prof. That was extremely informative. And And I'm sure there's a few questions already that have emerged from your presentation, which we will take at the end of this session. So we have 2 more presentations and then we'll go into a question and answer. Lindelani, are you ready? Either Lindelani or Tobozani? Whichever
yes,
one is. Okay.
Yes, I am ready.
Okay, great. Please go ahead.
Thokozani, please make it full screen. Yeah, thank you. Good afternoon, colleagues. My name is Nirani Larumbe. I'll be presenting a paper on the characterization of hydrogeochemical processes influencing groundwater quality. This will be a case study of the Soutpansberg region in Limpopo province in South Africa. Next slide. The outline of the presentation will be the background, the study aim, description of the study area, methodology, results and discussion, then conclusion. In terms of background, studies on groundwater quality and processes that are controlling the quality are important mostly in arid and to semi-arid region due to increasing pressure on water resources, owing to issues such as climatic variation, the drought, socio-economic development, and pollution. Also, more people in Southern Africa rely on groundwater for domestic use and irrigation due to climatic variation and also the socio-economic factors. However, current practices on this hydrogeochemical process research that are influencing groundwater quality focuses more on the determination of suitability of use and model without influencing policy change or improving the livelihood of people that are using the groundwater. Also, improved understanding of hydrogeochemical processes is important in achieving groundwater-related United Nations SDG goals, such as Goal 2, Zero Hunger, Goal 3, Good Health and Well-being, and also Goal 6 about clean water and sanitation. Next slide, please. So the aim of the study is to identify the hydrogeochemical processes that are influencing groundwater quality. This is assist in improving understanding of the aquifer, to also improve groundwater management and protection, and also it can determine the feasibility of a groundwater remediation technique suitable for rural environments such as the Soutpansberg. The study area is located in Limpopo province, the northern province in South Africa. This is a Soutpansberg region, which has also been identified and delineated as a strategic water source area for groundwater by WRC report. In this area, there are 12 bowls that are being monitored by the Department of Water and Sanitation from 1995 until 2021. There are also 2 geothermal springs in the area that are being monitored also. In terms of groundwater use, there's about 148 million cubic meter of water per annum that has been allocated for domestic water supply and irrigation area. And also in this area, environment, there's a decaying water storage and supply in infrastructure that are relying on more people relying on groundwater for everyday use. There's also small to large scale subsistence and commercial farming relying on groundwater. And also this a sedimentary volcanic aquifer of the Soutpansberg group. Next slide. In terms of methodology, groundwater quality data from 12 bores and 2 geothermal springs from 1995 to 2017 were found on record at the Department of Water and Sanitation. Groundwater was collected in 2020 October and in August and September 2021. Over 120 samples were collected, and the mean of those samples were used in the study. Parameters such as magnesium, calcium, sodium, potassium, and to sulfate were used to analyze these processes. In terms of data analysis method, a paper diagram was used to determine the water type. Give the diagram was used to understand water rock interaction. chloroalkalinities and bivariate plots were used to understand the interaction between groundwater and the host rock. Frixie was used to model the saturation index of groundwater in the area. Next slide, please. In terms of results, in terms of the hydrogeochemistry, pH range from 7.7 to 9.3, indicating groundwater is alkaline in nature, owing to high concentration of sodium, magnesium, calcium, and bicarbonate from lithological setting, which is a mafic to ultramafic igneous rocks. In terms of TDS, over 80% of the sample were classified as fresh, with only 14.3 classified as brackish. In terms of the contaminants in the area, fluoride was a problem with a mean of 2, southbound back 1, and also high nitrate were found in bowl at ZQM-GG1, MBA1, and TV1 in the area. For instance, ZQM-GG1 nitrate range, mean nitrate of 15, were recorded ZQM-MBI1, mean nitrate of 22 were recorded in this area. So salinity, fluoride, and nitrate were an issue in this area. Next slide, please. In terms of paper diagram, the nitrate was an issue in the shallow aquifer, in those boreholes where groundwater level is below 15 meter below groundwater level. That's where majority of the sample were as over 35 of the sample were classified as calcium bicarbonate, which is typical of fresh water. And also there was a mixed water of calcium, magnesium, and chloride in borehole with groundwater between 16 to 37 meter below groundwater level. In this area, the least dominant types were the sodium chloride, and also the geothermal spring were classified as calcium sodium bicarbonate, also indicating that there's a mixture of deep ocean groundwater with
I'm losing you, Lindelani.
Next slide, please.
Okay.
Okay.
Did it move?
No, it didn't move. Gibbs diagram, the ratio used, the two ratio used for Gibbs diagram, or indicated that rock dominance processes influencing groundwater quality in this source-span aquifer. Next slide, please. And to confirm the finding of a Gibbs diagram, correlation analysis were conducted. For instance, in figure A, the sodium to chloride ratio indicated that though the bowl that has salinity issues were plotting on the 1-to-1 equiline, which indicates or suggests that highlights dissolution, control quality in the area. And most of the sites without salinity, they deviated from the 1-to-1 line slightly, which also suggests the ion exchange process and also silicate weathering. And also in some of the area, bicarbonate was the measure ion indicate, also suggesting the presence of silicate weathering. When you go to figure B, where sodium chloride ratio were compared to EC, also the bowl that was highly sunlight in the ZQM PMA1, it was plotting on the one line which indicates highlight dissolution. The rest of the bowl, some were indicating silicate weathering of forward ion exchange or reduction of processes where There's an exchange of ion between calcium, magnesium with sodium. And when you go to figure C, it indicates that like the majority of the size slightly deviate from the one-to-one line, indicating weathering of carbonate minerals and also weathering of silicate minerals. Also, when you go to D, it's indicating the same thing, that silicate weathering or reverse ion exchange control groundwater quality in this area. Next slide. Alkalinities were further used to try to confirm the processes that are controlling groundwater quality. The three sites with the high salinity plot on the 0 line, indicating that either there's no ion exchange happening in the area, and those three sites are the sites that are highly saline. The other sites show that there's either reverse ion exchange or forward ion exchange controlling groundwater quality in this area. Next slide. To try to determine the source of nitrates in the area, nitrates was nitrates to potassium ratio and also nitrate to magnesium ratio were compared. Also, the sites where nitrate is high, the ratio between sodium, between nitrate and potassium, they were high. Also, when the ratio between nitrate and magnesium, the ratio were high when nitrate were high. This also suggests that there's a point source influence of nitrate in groundwater from the shallow aquifer, probably the application of potassium nitrate and also magnesium nitrate fertilizers as the source of nitrate in groundwater in this area. Next slide. Frixie was used to further confirm the dissolution of silicate mineral or dissolution of highlight mineral. In this case, we can focus on fluoride, which is a green triangle, which from this, it suggests that fluoride in groundwater came from the dissolution of fluoride in the hot spring, as also both the calcite or carbonate mineral and fluoride mineral in that area are both below the zero, are both negative, indicating that there was a dissolution of fluoride leading to elevated fluoride in groundwater. Also, the dissolution of highlight minerals is obvious there, where in all the borehole, it indicated that there was this dissolution of highlight. Also, in terms of silicate, precipitation of silicate was noted. Also, the borehole, which is more saline, where the TDS is almost 1,700, indicate that here there was also dissolution of a silicate and highlight mineral, meaning these processes are the ones that are the major processes that are controlling groundwater in this area. Next slide, please. And now that we know that these are the processes that are controlling groundwater in this area, what can we do to try to improve groundwater quality in this area, to improve the health and livelihood of people? For instance, the hot spring at Sisilom, I came across this headline within a local newspaper that was saying, at Sisilom, water is cheap, but remember to brush your teeth. Meaning people are taking water from the hot spring, which is high in fluoride, take it to the house and drink this water without any form of remediation, or maybe the knowledge. They just see that most of them are suffering from dental fluorosis. So as scientists, what do we do to share the research outputs with the community that are using groundwater? Because discussion in this paper indicated that there's no awareness that is being carried on after a research. We have some sort of a parachute type of research, where as the researcher come to a certain area, collect data, do research, and publish the data, and without coming back to the community to share the data with them. Sharing the data with them will help, for instance, to improve their health in line with SDG 3, and also it will also improve their livelihood. And also there's also a need to find a suitable remediation technique for such scenario where people are using communal spraying as this one for water use. And also when you go to nitrates, also that can cause health issues. People are drinking groundwater that the nitrate concentration is high, salinity is high in this area, and they are not aware of the consequences, health consequences that can happen by drinking such water. All in all, research output should be used to improve the livelihood of people, enhance groundwater management and protection policies, and also groundwater allocation policies or processes can be improved by applying research output on groundwater quality. For instance, in this area, probably there's an area that people are irrigating with groundwater that's not suitable for irrigating, and that can also impact their livelihood. And also, there is no way we, as water users, we are going to improve water quality in line with SDG 6 if we're not sharing the output of our monitoring data or research output with water users and communities such as this. Next slide, please. In conclusion, various methods applied concluded that weathering of minerals, dissolution of highlight, ion exchange, and anthropogenic input influence groundwater quality in rural setups such as the South Pansberg area. Also, the dissolution of fluoride mineral was determined to be the source of fluoride in the geothermal spring. But also, the main discussions suggest that research output on groundwater quality are not being used to improve health and livelihood, improve groundwater quality related policies, and also water allocation. Again, it will be impossible to achieve SDG 2, 3, and 6 without sharing research output on groundwater quality with communities and groundwater users in general. And also, it is recommended that an appropriate groundwater remediation technique or the feasibility of it being studied or implemented specifically for rural communities. Thank you.
Thank you so much, Lindelani. That was bang on time and extremely informative. Thank you also particularly for bringing in the benefits to SDGs in line, the benefits to livelihoods as well in line with the SDGs. So we will now have our last presentation, colleagues, and then we will have a few minutes remaining for questions and answers before the end of this session. Eli and Lobina, are you ready for your presentation?
Oh, yes, I'm ready.
Thank you. Please go ahead. Are you, by the way, Eli, are you part of the group of celebrities under 35?
No, unfortunately, no.
Ah, okay. Okay, great.
Are you able to see my slide?
Yeah, it seems it's coming through. Yes, there it comes through now. You can see it.
You can see it.
Yes.
Okay. Unfortunately, I'm on one hour of load shedding now, and I was afraid that time might hit me.
Okay.
Yeah. Good afternoon, everybody. This is Liliburu. I'm presenting the study of hydrochemical assessment of groundwater quality of the Grootfontein aquifer in the Northwest Province of South Africa. This study was basically submitted in the completion and fulfillment of my Master's in Environmental Sciences with the Northwest University under the watchful eye of Professor Lobina Palamuleni. So this study was built on facts.
Sorry, Eli, can you put your presentation in a presentation mode, please? I'm sorry, Chair,
No problem, thank you.
Okay.
So you see on top where it says slideshow, go to the right. Yeah, that's it. Yeah.
Is it fine now?
Perfect.
Yes, it is perfect.
Thank you.
So I was saying the study is based on the fact that groundwater is part of the hydrological cycle, and it is an important source of water supply worldwide. And groundwater resources are varied depending on their location, occurrence in time, characteristics, accessibility measures, size, as well as measures that are taken to harness it that is inconsistent with its demand. Many authors have agreed that because of demand for drinking, irrigation, and growing industrialization, groundwater has faced and is becoming a more important commodity. Because of that, the aim of this study was to investigate the hydrochemistry of the Kootfontein Aquifer in the Northwest Province of South Africa. And we are basing this study on achieving the aim with the following objectives. That is to determine the physicochemical concentration of groundwater, quality parameters, and to assess distribution of major cations and anions. We found that the study is of importance to take place because we want to build an understanding of groundwater for sustainability as well as its protection against pollution. Also, we wanted to assess the health of groundwater to human as well as in crop irrigation. Okay, now the study, like previously said, was conducted over the Northwest Province, and the study area is situated over the Northwest Dolomite. So we are looking into the Kootfontein Aquifer over the entire Dolomite. And basically, looking into this study area, we can see that the aquifer supplies many towns around it. We have cited towns such as Zeerust, Lichtenburg, Venterstop, Koster, Colini, and Mafeking. They are more dependent on the water that comes from this aquifer. So it's basically important to take this study in order to test the hydrochemistry of this aquifer. So the aquifer briefly was divided into 3 sectors: Sector A, Sector B, Sector C, as we see. The reason for integrating this aquifer into 3 sectors was solely because of the following. We're looking at the study, and we found out that there are 3 major geological formations that are prevalent over the study area. And if we look at section A that I posted previously, you will see that it is more of the calcrete surface limestone and the hard pans, while section B, it is dominated by the malmanganese subgroup, and section C, it is mostly dominated by the alluvium, colluvium, alluvium, clays, scree, and sand. So basically, it was important to integrate this study area into 3 regions with different geological structures to see from which geological structure do we get more of the geological hydrogeological impurities within the water in the aquifer. So there were around 17 water samples that were collected in this study. And we used the following methodology. First and foremost, we applied an on-site data analysis that was performed on pH, that was performed on temperature, electrical conductivity, as well as total dissolved solids. The reason was to avoid an external influence on the water if we cannot test it on site. So we decided to test the water on site before we can transfer it into the laboratory, where the second analysis took place. Basically, in the laboratory, there was a test for the major ions, analysis for the major ions using ICP-MS, but we're applying a total quad method in that regard. But since sulfate could not be obtained from the ICP-MS, we obtained sulfate by oxidation equation. And we also obtained bicarbonate through Henderson-Hasselbalch equation, as you see there. Same applies to nitrate. Nitrate, we obtain nitrate by using nitrogen concentrations that we receive from ICP-MS. The total hardness also was obtained using the concentration of calcium and magnesium that were obtained from the ICP-MS. So if we look at the results, the result for our study was divided into two, the physical parameters and the chemical parameters. And the chemical parameters were further divided into the cations and the anions. So from the physical parameters, the summary of the physical parameters, it's evident that total dissolved solids and electrical conductivity recorded higher values as said by World Health Organization as well as Department of Water Affairs, South Africa. One can argue that higher values of electrical conductivity may suggest mineral dissolution in the groundwater, while maybe salt absorption may be the cause of the high total dissolved solids in the groundwater. But it is important to note that both these parameters can result in the corrosivity as well as increased solubility of non-soluble compounds, such as maybe calcium carbonate. We look again on the summary of chemical concentrations of cations. Remember, I said the chemical parameters were divided further into two, the anions and the cations. So looking at the chemical concentrations of cations, the table summarizes those concentrations. In this summary, we can see that calcium and magnesium recorded higher values as compared to other concentrations. Calcium abundance in the groundwater may be because of the natural occurrence in the Earth's crust, and magnesium is contained largely in the dolomite, which is abundant in that area. When we visited the area, we found that dolomite, and in the study area map, we saw that dolomite is abundant in the area. So the chances that magnesium is abundant here is because of the dolomite that is present there. So this dolomite, when it's leached into the groundwater, it increases magnesium concentration in the groundwater. And if we look, both of these parameters are responsible, calcium and magnesium are responsible for water hardness. Further, if we look into the summary of chemical concentrations of anions, we see that amongst them, there is chloride and there is sulfide, which basically recorded values beyond requirement limits. Chloride, one can say, forms basically from irrigation discharge returns, while sulfate may be as a result of weathering of gypsum that is in abundance in the area. But too much of chloride in water may increase as mineral content increases as well. But to date, there is no recorded health hazard relating to increased amount of chloride in water, especially drinking water, of course. And while on the other hand, high sulfate content may result in the scale up in the water pipes, and if there is a continuous scale up in the water pipes, it might eventually result in those pipes busting up. Okay, which of course we do not need. We studied the results of geochemical phases of groundwater within the study, and then we used the paper diagram to assess or analyze groundwater parameters. So more details output of the paper are presented in this table. Accordingly, the results of paper are dominated here by calcium chloride type, and it is basically followed by magnesium bicarbonate type. You see that calcium chloride type was dominant on 7 boreholes, while magnesium bicarbonate type was found in 6 boreholes. So calcium and chlorine may result, because of farming activities within the study area, those inorganic absorption of salt, thereby they increase calcium and chloride in the area. And at the same time, silicate rich rocks such as dolomite we have mentioned, as well as chat, which are abundant in the study area, may lead to increased magnesium bicarbonate water type. So that's basically why we have got increased magnesium bicarbonate water type as well as calcium chloride types. We studied the relationship between the lithology and water composition in the area, and then we captured the result and analyzed the result using the Gibbs diagram. And we have found out 3 distinctive fields that are used, like rock-water interaction, evaporation dominance, precipitation dominance. And water interaction in Gibbs diagram is used to understand the chemistry of groundwater, and thereby it is plotted by total dissolved solid against proportion of sodium to sodium and calcium, and then we plot again TDS against the proportion of chloride to chlorine and bicarbonate. So in this study, we found out that rock-water interaction is dominant, and this shows that there is high dissolution of rock-forming minerals as a result of chemical weathering in the area. So basically, these are our findings in this study. So we are saying the results of the study reveal that most of the groundwater samples are within the desirable limits of drinking water guidelines as provided by South African water quality guidelines, as well as World Health Organization. And generally, the water within the study is fit for consumption. We have also studied that the hydrogeochemistry within the study is dominated by calcium chlorine type, physis, as well as followed by the magnesium bicarbonate type. So the study revealed that there is only one type, sodium bicarbonate, and mixed type of calcium to sodium bicarbonate. So in general, the geologic controls within the study are governed by silicate weathering, ionic exchange, and chloride solutions. From this study, we may recommend that, I was listening to Prof. Tijani, if I'm not mistaken, he alluded the very first point that I have a recommendation on the extensive groundwater quality parameters need to be studied, which include the presence of heavy metals within the aquifer. Grootfontein is located within the Northwest Dolomite and is based on the flow recharge from heavy metals that are produced from the East Rand mines near Johannesburg. So also we are saying water bodies, especially the underground water, do not occur in isolations. They are interacted with lakes, wetlands, aquifer, as well as rivers. So we need a proper mitigation measures to preserve the quality of water within the Grootfontein aquifer. Therefore, the studies to understand the systems using the quantitative and qualitative assessment, really it needs to be done. That's the services provided by the groundwater, such as base flow to rivers and wetlands, need to be recognized and protected within the planning framework. And I would like now to take this opportunity to thank the fourth SADC Groundwater Conference on behalf of myself and Prof. Palamuleni. Thank you.
Thank you very much, Eli. That was very informative, very scientific and informative. We appreciate your presentation. So colleagues, this brings us to the end of the presentations that we will be having for this session. I'm just noting some of the questions that have been raised in the Q&A section. And let me start with, okay, I'll also now go to some questions that were posed. Eli, there's a question to you about, it's from Gladness. She's asking, was the subdivision of the Grootfontein aquifer based on the dolomitic compartment subunits, or was the subdivision, or what was the subdivision based on? So what was the subdivision of the Grootfontein aquifer based on? Are you able to answer that, Eli?
Basically, the study was, like I said, was divided into three major geological formations that were found over the Grootfontein aquifer. So the dolomite, which forms part of the Malmanis subgroup, formed part of the subdivision that was studied over the Grootfontein aquifer, but not only the dolomite, but also the surface limestone, as well as the alluvium, as listed previously. So it was not basically focused on the dolomitic compartment, but it was part of the compartment in which we did our study. Thank you.
Okay, thank you. Then a couple of comments were made on Lindelani's presentation. One from Ligava saying that it's important that the research output must reach the communities for the betterment of livelihood. And Charles Pule also talked about the importance of sharing the feedback with communities in all the studies that were conducted. Prof. Gomo, you were requested by Mzugisi to share your paper. I believe that all the presentations will be shared. Is that correct, Mr. Munyai? Or
that's correct.
yeah.
After the conference, yes.
Okay. And then Mukwena also gave a comment agreeing with Lindelani on the point of feedback, the importance of feedback to the community to let them know the outcome of the research. They can also help in protecting the aquifer and the resource. This is from Dr. Portia Mukwena. A question to you directly, Professor Gomo. Can the determination of the borehole sustainable operation yield be affected by a rise in water table in saturated zones, or this holds only for unconfined aquifers? This is a question from Steve Kumwenda. He's saying that they are experiencing quite a number of seasonal boreholes in some areas of Malawi. Prof, did you get the question?
Yes, thank you. I will try to answer, but maybe it's what in this case he was asking about the rising of the water table in the typical unconfined aquifer. I was speaking mainly for the typical confined, but I would perhaps maybe if they are linked together, like typically your leaky aquifer system, I'm sure they will have a contribution to that. I think it can be affected by that rise, perhaps, but you would think maybe as we rise, we probably might get a more inflow into the aquifer, but we can have a chat, Steve. I don't know if you allow me. I think there was I responded on the chat from Kevin Peterson. He had asked me to maybe expand on the derivative. I don't know if I can do that. I promised there, but I replied to the chat.
No, that's fine. That would be fine for all of us to hear.
Okay, that will be just, I think, very small, maybe 2 minutes. I understand maybe what Kevin was, because I highlighted the use of the derivatives here when I was actually trying to simulate the normal constant discharge. But what I indicated is that right there, we see a dip in the derivative, but which sometimes we wouldn't be able to see in our normal drawdown time. This is the normal drawdown, this is the derivative. But just maybe to expand a little bit, what I've just done, I'm just zooming on there where actually there is that change. So if you zoom in there, you can actually be able to see that what happens there. If nothing had happened, we would expect the trend to keep going like that. But because of that slight flattening, which is obviously like that, the reason was actually because when we were pumping in this aquifer, we are drawing down the water level, but we were getting very close to the top of the aquifer, which is more like where most of the water is coming from. So there is that tendency because we are getting to where most of the water is coming from, to actually try to balance with to almost stabilize with the flow. But what the derivative allows us to see is actually be able to see that associated flattening, which actually, if we go back we wouldn't be able to see that if we were just looking at the drawdown. I thought that perhaps he wanted me to expand on the value of the derivative, which sometimes, because it's sensitive to the draw as compared to the drawdown, it enables us to see things that we wouldn't just see by looking at our normal typical drawdown data. Thank you.
Thank you very much, Prof. I think that clarifies it for everyone. There was a suggestion from Simon Banda that we should, for the scholarships, that we should have one student at least from each of the SADC countries. And then another question to you, Prof, from Pete Kinabatu. He's asking, I'm curious to know if you would consider variations when applied to non-homogeneous setup, which is close to the reality concerning most of aquifers, including leaky aquifers. So would you consider variations when applied to non-homogeneous setup?
Okay, thank you, Chair. I had responded, but let me quickly summarize. And we're looking at illustrating some of the simple heterogeneous system. That's what non-homogeneous. But I must say, in principle, the method is applicable in both homogeneous and non-homogeneous, because what the method does, it uses drawdown measured in the pumping well and the derivative of the drawdown. It does not use the typical classical parameters of the ties, or the typical parameters like storagivity or transmissivity. So I think the most important thing is to be able to define the critical zone whereby we say the level should not drop. Typically, your fracture position on the top of your confined aquifer. And I do think but we have a task now to just also illustrate that, because I totally agree. I think it would be good in some of the simple homogeneous setup to demonstrate how it can work. We're hoping to publish some work there. Thank you.
Okay, thank you very much, Prof. And once again, a huge thank you to all the presenters. It's bang on 1 o'clock now. I think my job has been done. It's been a pleasure to engage with you on this session, colleagues, and it's extremely informative. I learned a great deal. I'm sure all of us have learned a great deal.